Suppose secant theta is equal to 4. Now, anytime that you're given a reciprocal trig function, if you know secant theta is equal to 4, you know right away that cos of theta is 1 over 4. Determine the exact values. Okay, this word here, exact values, comes up a fair bit. That means it's going to be a non-calculator question that you're going to have to leave your answers with square roots and not plug it in and get decimals. Determine the exact values of the other trig ratios from 0 to 180 degrees. Okay? Well, we need to draw a triangle. What do we know about this triangle? We know the opposite and the hypotenuse, not the opposite, sorry, cos is adjacent. We know the adjacent side and the hypotenuse. Do we know what quadrant it's in? Well, according to the cast rule, it would be either in quadrant 1 or quadrant 4 because it's positive. Does that make sense? Cos of theta is positive 1 over 4. Because it's positive, the cast rule says it's in quadrant 1 or quadrant 4. The question also says we only want to find it in this domain from 0 to 180. 0 to 180 says only look in quadrants 1 and quadrant 2. So we wouldn't be looking in quadrant 3 or quadrant 4. So they've given us enough information to tell us this triangle is in quadrant 1. So if I draw a picture of my 4 quadrants and draw a triangle and label my angle or my reference angle, in this case, your reference angle is exactly the same as your angle because it's in quadrant 1. But we get into a habit of labeling it as our reference angle. Cos is the adjacent side, so I can say this side is 1 and this side is 4. And now a squared plus b squared equals c squared. C squared is going to be 4 squared, which is 16 minus 1. Again, you're going to get really good at doing a squared plus b squared equals c squared in your head to write the other side. You don't need to show any work for that. You can just mental math. 16 minus 1 is 15, square root of 15. Well, in this case, you see, if I write it out, and it's not bad to write it out right now, you can see that the hypotenuse is going to be 4 square root of 16. And one of the sides is 1 square root of just 1. And you need to find the other side. So now I'd have to move the 1 over by subtracting. And you would get that b is the square root of 15. Okay? If you want to show that work right now, but as you go along, you're going to just do that as mental math. Now we need to find the other trig ratios. We already know secant. We already wrote down cos. So the other ones that we need to find are sine of theta and tan of theta, as well as the reciprocal ones, cosecant theta and cotangent of theta. Now sine, opposite over hypotenuse, root 15 over 4. Tangent, opposite over adjacent. They'll both be positive because we're dealing in quadrant 1 where everything is positive. And then cosecant will be the reciprocal of sine, and cotangent the reciprocal of tan. So in part A, it just said look between 0 and 180 degrees. In part B, they say look between negative 360 and 360. So what we did initially with the cast rule is going to come into play now in part B. Because cos is positive, you knew that one reference angle was in quadrant 1, but it's also possible that you could have had another triangle with the reference angle in quadrant 4. And these triangles are exactly the same as we drew before. This is 1, this is 4, this is 1, this is 4, this is root 15, this is root 15. And these would be right-angled triangles. And the first thing we can find is we can find our reference angle. Well, we can find our reference angle by using the same trig that we learned back in grade 10. In grade 10, trig was so nice and so simple. It was just right-angled triangles. It was just SOHCAHTOA. Well, that comes back into play here. If I look at my reference angle, it's part of a right-angled triangle. I can use SOHCAHTOA. In fact, I know all three sides, so I could choose sine, cos, or tan. In this case, I would probably choose cos just because it was given to us with nice numbers. I might have made a mental math error when I figured out the square root of 15. There's a possibility for that. So if I want to use the numbers given to me, which was the 1 and the 4, then I'm not going to make the same mistake again. How do I find an angle? Well, I would take out my calculator. Right? In my calculator, I would type in cos inverse of 1 over 4. So take out your calculators right now. And do cos inverse of 1 over 4. And check if you get 75.5 degrees. If not, your calculator might be in a different form. You want to make sure that it's in degrees. So we're asked to find it to the nearest degree. So I'm going to round this right away to 76 degrees. Some useful calculator tips that you can use. Okay, your calculator has some nice things built into it. Right above your on button is a store button. I like to use the store button when I know that I'm going to use a number often. So I know that I'm going to have to use my reference angle to figure out a bunch of different angles here. So what I can do is I can hit that store button, and it says, where would you like to store your answer? The thing that I use the most is just X. Store it as X because it's an easy button to push. But you can also go all these letters. You can go alpha A, alpha B. You can choose all the different letters if you'd like. If you do that, it stores it as X. Now, why would I want to maybe store it as X? Well, I need to find all the angles between negative 360 and 360 degrees. So negative 360 to 360 degrees, because that's the domain that was given to us right here in the question. With negative and positive angles, I like to break it up and think this means 0 to 360 degrees in the positive direction and 0 to negative 360 degrees in the negative direction. Does that make sense that both of those would be included? And so if I think about those separately, drawing my positive direction here in green, this would be one positive one, and this would be my second positive one. And if I draw my angles, my negative angles in red, if I start at 0, this would be one negative angle, and this would be my second negative angle. So in the end here, solving for theta, I should get 4 answers. 2 positive answers and 2 negative answers. So after I found my reference angle, I can now find my actual values. Theta is going to equal. Can you see in quadrant 1, the green one, the positive one, would be exactly the same as my reference angle. So I can write one of my answers is going to be 76 degrees. My other positive one is going to be this one in quadrant 4. Can you see that if you took all the way around 360 degrees and subtracted your reference angle, you would get your answer? So what I can do on my calculator is I could do 360 minus 76 and get my answer that way, because my reference angle was 76, and get 284 degrees. I could also, since I've stored my value as in my calculator as x, I could just do 360 minus x. The nice thing about this is it keeps all of the decimal places, and we get 284.4, which rounded to the nearest degree would be 284. We get the same answer, but we haven't rounded until the end. And one of the things with exact values, they will deduct marks if you round early and your final answer is off as a result of rounding early. So technically, we should always keep all of our decimal places right till the end and just do our rounding at the end. In this case, we also get 284 degrees. For my negative angles, and I'll write them in red here, can you see that this negative angle in quadrant 4 would be exactly the same as the reference angle, just in the negative direction? And maybe you can see that to get this negative angle would be the same idea, 360s all the way around minus my reference angle. This one will also be exactly the same, just in the negative direction. It doesn't always work that they're the same in the negative direction, but in this case they are. So questions for practice on this one are 9, 10, and 11.